Okay, well, we'll get started here, and if Eric gets his mic issues sorted, then we'll come back to Eric. He had a presentation he wanted to talk about an application, a practical application of a quartz crystal. Tonight, I'm going to talk about some RF measurement techniques, and then we'll go into a bit of roundtable. And of course, if anybody wants to bring up another topic or subject or questions or whatever, as per usual, just shout and go ahead. Okay, let me share my screen here. Okay, we can see that, guys?
Yep.
Okay. All right, RF measurement techniques. In this case, it's aimed at a spectrum analyzer connections, connecting your circuit to a spectrum analyzer and in detail with a crystal filter characterization. It started off, it's a great subject, this, because it started off with several conversations I've had over the years, off and on with various people. And this particular PowerPoint presentation is just one scenario of many of how you connect to your circuits for some measurements. And this one kind of came out of discussions, really, which started with Dave and I with the D612 project and then carried on. And then it came to light again fairly recently when I was doing some testing of the receiver portion for the Phoenix project. So here, I'm just showing the schematic of the crystal filter for the receiver, and the red arrows are depicting the measurement locations that I've picked off for the various measurements I'm doing. Some of these measurements are done with the 612 installed, and sometimes not, just depending which method I'm doing. The load resistors that we'll be talking about are connected at this particular point here. So in the case of T2, I would lift off here. I'll just put my mouse over here. I'll lift off the wire here off of the cap. No, actually, sorry, over here, and then put a resistor for the load resistor, and then that would connect to the SA. And the blue arrows just represents where I took another method where I wrap a turn around the toroid and then connected those to the spectrum analyzer, the tracking generator on the left, and then the RF in on the right. So this is just a quick layout of those connections. And in the bottom line, you can see where the spectrum analyzer is connected to the circuit through the toroid, and that's a coupling. It's not a direct connection. And I just put down on this particular toroid, the closest I could get was a half a turn of 60 ohms. And if anybody has an idea how I can get a half a turn on a toroid, please let me know. And one turn jumps to 236 ohms, and then two turns 946. And the impedance on the SA is around 1500.
So here, can I ask a question before you?
Yeah, sure. Go ahead.
Ask a question.
Yeah.
What were the values on this previous slide? What are they? Is that impedance? Yeah, yes. The 60 ohms. What is that? That's
on the toroid. That's on the these toroids here. Yeah. The FT5075. Yeah. If you wanted 50 ohms, the closest you can get is a half a turn on that toroid with your wire.
Oh, got it. Okay. Okay, got it. Thanks. So that's good.
That's why I say, Michael, if anybody knows how to get a half a turn or a quarter turn, let me know. Although that could be a subject of another test. But anyways, stick a loop partially in there or something. I don't know. Anyway, that's what that is. Okay, so in the upper left-hand corner was actually, this is what kind of started the latest version of how to connect the spectrum analyzer to a circuit. And here I just connected it directly to to the crystal filter and came up with this result. And as you can see with the dips in there, again, upper left here, I wasn't very happy with what I saw, especially since the math all said that the profile of the filter should be better than that. So when I saw that, I thought, oh, gee, what are we going to do here? So that's what kind of got me going on it. And then from there, we progressed in, okay, let's dig in here deeper. So on the right, I've done a one-turn toroid connection, and you can see quite a bit of a difference in the layout. Now, in this series of scans, I did not move the markers. I left them in the position that they were based on the no load scan. May not have been the best idea to do, but that's what I did this time going around here. But what it does show is how the profile of the filter shifts, and you can see where the peaks. So the markers represent the peaks from the no loads on the filter, and you can see how where now I put a bit of a load onto it, and there it goes. It's shifting. Down here, I only had a 1.2K load, or I could find at the particular time resistor, and this was the results I got there. So again, different than the one turn, but basically pretty close to the same. And then over here, why not? I got curious. So does a two turns on the toroid connection, and the power level increased, and that was not unexpected. But again, the frequency had shifted a little bit, not a huge amount, but it does shift. And here is just a closer look of, well, the two scans that I think is meaningful. You know, the one with no load didn't really, I don't think is meaningful. And but however, I think a comparison between loading, using a resistor as a load to feed your how should I word it, to emulate the load of, or the impedance of the 612, and then here having everything connected, and then just taking a turn off of the toroid connection. So those are the two comparisons there that I think are important. Now, on the left, I just took the readings and I plotted them. And the upper one is the one with the no load, and you can see that that's interesting. But when you compare to the 1200 ohm load, the one turn on the transformer and the two turns, you can see the profiles are of that filter were the same, even though these are not the peak measurements. They're just in the same spot, but the profiles are very similar. So that was interesting. Over here, because I had already removed things, the setup a little bit, I decided I should really take a look at the peak measurements, and which is what I did here. And I estimated by just looking at the picture I had taken. Now, I don't have an explanation as to why the very first reading here did not match, but here they do line up perfect. So I suppose I should have gone back and redid the testing here, but I didn't. But what I did instead was, well, here, I'll come to it in a minute. So here I did I put the circuit, did another scan, and this time I put 612 in it and took it out just to see what the difference is. Same thing with the power on or off, and really there was a negligible difference to the profile. There was a minor decrease when you turn the power on, funny enough, of about 0.3 dB. Then I got curious. I just added some resistance to the 612 just to see what would happen, and it raised the skirts of the profile, but it did not alter in any way the where the red circle is denoting. Let me just do something here for a minute. Let's see, it's time on 8. Okay. I decided to redo the testings. I found a 1.5K load, which is closer to the impedance of the 612. and I redid the measurements. And this time I was going to do the measurements, and I'm just going to alter the peaks as to wherever they are, and then see what we come up with. Now here's the 1.5K load, and then here is where I took a 1-turn toroid connection. So you can see what the difference here is. The amplitude has come up. The profile of the filter itself is pretty much the same. And there's a slight shift in the frequency, very slight compared to 2, but it's not really worth mentioning, really. Okay, here is the 1 toroid connection, and my screen's blocked there. What does that say? SA612 installed, was it? Yeah, I think that's what it says there. Yeah, installed. Yeah, okay. So just to quickly go back to the 3, just to see what you can see how the profile is changing a little bit. Not a huge amount, but the amplitude does. So again, I did another test. I did another plot of it, and I didn't bother with the 2-turn transformer because it was just out of curiosity as to what it did. But what was important was the comparison between the no load, in this case 1.5 K, and then the 1-turn transformer. So we've already decided that the no load connection is meaningless. And so between the 1-turn and the 1.5K load resistor, we can see that other than really the amplitude is different, and everything, the profile is the same. There might be a slight difference in the slope of some of these the angles there, but that is basically about it. So this one here, I took a different approach, basically, I guess, to confirm what the other readings were doing. And here I just put a signal generator on the front end of the receiver, and I just cycled through the various frequencies, and I measured the output, and then I plotted the values, and this is the profile that I came up with, just pretty similar as to what everything else was doing, but I came at it from a different angle. So conclusions. Okay, so it's important to properly simulate the impedance of the 612. Well, that's for sure. The no load shows huge inaccuracies in amplitude and the profile of it as well. The value of the load is not overly critical, depending on what you're trying to determine. If for absolute measurements, yes, the load is critical. But if you're going to be doing like a I forgot to mention that one of the slides there. I did do a 3 dB measurement on it. But so if you want to do a 3 dB measurement and your profile, taking a look at that, the load doesn't seem to be overly critical. Either connection methodology will work, as you say here, determining the filter profile, including its position on the frequency domain. Again, there was a slight shift on it, but not a huge amount. So we have 2 techniques. One I call the OOI technique. That's the one where you plop the load resistor in series with your SA on the RF input. And then the POA technique, which is the 1-turn wrapped on your on the toroids. So the ultimate conclusion, and because Dave is not speaking to us tonight, and we can twist this my way, and it's my presentation, I conclude that the POA methodology is the most accurate. And the reason for that is the circuit is, as designed, is intact. You don't have to delete anything, you don't add anything to it, or substitute in a resistor, or those kinds of things in order to make these measurements. Connection to the circuit is accomplished by transformer coupling, which minimizes any measurement influences. And therefore, I believe amplitude measurements is the most accurate when accomplished by the POA method of connection. So again, how accurate, I'm not 100% sure, but that's open for debate. but I think it's the most accurate measurement. And if you're looking after profile and all those kinds of things, then it's not a huge difference as to which way you go. Now, this one's a bit, I guess in retrospect, a bit silly, but at the time when I was in the middle of doing everything like that, I came across what would the effect of the filter profile if you reverse the leads. Would anybody care to just jump up, just pop up an answer?
What do you mean reverse the leads?
Well, if you reverse, like you've got your spectrum analyzer, the tracking generator is connected to the input of the crystal filter, and the output of the crystal filter is going to your input of the spectrum analyzer. So reverse those.
Is the crystal filter mirrored on the input and output?
Okay, that's what you're saying. That's your answer, Ken?
No. Is the filter mirrored?
No, the filter as you see it there, where you saw two small humps on the low side, and then you got a little bit of a flattening out on the lowering down on the right side.
No. The input is the input. How do I go back to your filter, your schematic? So 100. No, it shouldn't make any difference.
Okay. Any other comments?
Yeah, it's symmetrical, right?
Yeah.
The filter is symmetrical, isn't it?
Okay. You know, when I got caught up in all this, I thought to myself it would be reversed. I wasn't sure. So it wasn't until I had retrospect that that I realized why it wouldn't make any difference at all. So anyway, so I did do it just to see what would happen, and then you can see, I guess there's a slight difference in something, but really, in fact, it's nothing.
I would have thought there shouldn't have been any difference because the filter is the same when you look at it either way.
That's right. So I think the only reason why there might be a bit of a difference on the right-hand side there, if you take a look here, this one seems to be, a little bit lower than over here. And you know what? That could just be, this stuff is so sensitive that when you move the leads around, that might account for some of that little bit of a difference.
Exactly.
So, but then, so for a discussion on this a little bit there, I guess it comes to mind then, can the impedance of an IC be accurately represented by a resistor? Because there was a difference there is a difference, not huge, but there was a difference, at least in amplitude. Anyways, there was a noticeable difference between where I just took one turn around a toroid, or the other methodology was, disconnect from the 612 and you just put a resistor in there to simulate the impedance of it. But is that an accurate representation though? Any comments?
Yeah, it should be, because the pin is a 1.5K impedance with a 3 picofarad cap. Now the difference might be is that 3 picofarad.
Well, that's where I was coming with, because what's inside the chip, there could be all kinds of things, inductance, capacitance, and all those kinds of things, and yet you're replacing that with a purely resistance thing.
Yeah. Can you go back to the schematic, a couple of comments?
Sorry, what was that, Michael?
Can you go back to the schematic just to clarify exactly what you're doing with your essay?
So what
I think you said is you put the tracking generator on the input.
Sorry, Michael?
You put the tracking generator on the input.
Yeah.
Let's say if it's just the filter, you'd put the tracking generator at the bottom of C8, let's say, and you put the output of the tracking generator on the bottom of C8, and the spectrum analyzer you input the RF input around the. Is that what you're doing?
No. When I was doing what I call the OOI method, the load resistor would be connected here, and then feeding the output directly. Same thing over here. You disconnect off of pin 1 and put a load resistor in there and feed that to the RF in on your tracking generator. or sorry, on your
So on the left-hand side,
left-hand side is
on the
where the
left-hand
tracking
side-
generator is connected.
okay, so you feed the signal in through C4 and
Yes.
measure it on the output by lifting that pin.
And then when I changed the methodology
And-
to around the transformer, I would then replace this back on to the SA 612 on both cases here. And then I took one turn through the toroid. So this one turn through the toroid here on the left would go to the tracking generator. Over here would go to the RF in of the spectrum analyzer. But these connections are now.
Okay, and
Sorry?
when you're putting the tracking generator and you're putting it through a resistor, I take it. Is that what that's the resistor, load resistor you're talking about?
Yes, on the load resistor point, you would connect one end of the resistor to this spot here, and then that would feed the tracking generator.
Got it. Okay, I understand.
Yeah.
And you didn't have to protect the tracking. You didn't have to protect the SA input with attenuation or anything, or did you?
In this case, no, I did not. And this is kind of spelling it out here how I connected it all up together. So your crystal filter goes to a toroid, then to the resistor, and then directly into the spectrum analyzer. That's method one. And then the other method is everything's connected in line here as per normal or as how it's designed, and then the SA is tapped in through the toroid, through a winding on the toroid for the second methodology. Okay, so now I did make a little bit of a fun here between the OOI and the POA methods, but in reality, it came about from Dave and I collaborating on a couple of projects from a distance. Him being in now Paris in Ontario, and I'm out in Kingston. And then, of course, when we're doing those kinds of things, we're in two different shacks working on the same project, more or less. There's obviously going to be an inevitable difference in approaches of how we do these things. And then, of course, this creates, which way is better, what's the best approach, and of course, in this case, it resulted in a positive way because further understanding of these circuits, and of course, more learning opportunities, and that we had not really thought about before. And we certainly, when we started the project, we didn't think about different ways of connecting our equipment up to the circuits. I even I didn't include it in here, although I guess I could have. But I even went down the path of taking my scope probe and then making measurements to the SA with the scope probe on with 1 meg to see what kind of results I would get from there. But I did not include that on here, obviously. So I think collaborating with another person on a project is a really good way of approaching projects, and I would encourage everyone to do the same. So that's all I've got for this one. If anybody has any questions, we're all ears.
I got
Hey,
one
Peter,
more.
I got a couple of questions.
Yep.
Okay, Peter?
Yep.
Can you hear me okay? Okay, first, when you did the measurement with the transformer, the tap, was the NE602 powered on?
I did both, on and off. And
okay, that's fine.
Yeah, no. Well, here's the difference. When the power was turned on, the amplitude went down about 0.3 of a dB.
Yeah, you have to power on the device because the device has got active components in there,
Yep.
and they will change the impedance. And in this case, it didn't change it that much, but you got to make sure you power it on.
Yeah, the takeaway was it did affect the amplitude a little bit, but it did not affect the profile of the filter.
Yeah. So next question. Okay. So if you've got a transformer, okay, you've got a primary and a secondary, and you do a tap on it, you're introducing a secondary, and you're changing the way that transformer behaves because you're now introducing, you're taking magnetic flux out of it. You're changing the way that transformer behaves because you've introduced a new secondary on that transformer.
I agree with what you're saying, Dave, but I have no idea as to. I guess the discussion is what's the difference? Like, is the effect that you're doing there greater or lesser than just simulating with a straight resistor?
Yeah. I don't know, but I'm just speaking facts.
Yeah.
But and it may be because you've got a 1500 ohm primary, a 200 ohm secondary, and a 50 ohm tertiary, a second secondary of 50 ohms, because your signal generator is 50 ohms, right?
Yeah.
But since you can't do half a turn, you're doing a turn. I don't know if that means it's 100 ohms.
Well, it's about 600. No, sorry, it was about 200. What? Let me see.
Yeah, because it's four times each turn, right?
It's 236 ohms with one turn.
Yeah, so you're introducing another 200 ohms into that transformer. So that transformer now is going to be transforming things differently, because the power in has got to be equal to the power out. So the power out now is shared between the first primary, the first secondary, and the second secondary. The power has to be split.
See, the other thing, Dave, is if I could have gotten 50 ohms on that toroid, would this yellow, which is the one turn line, be much closer to the resistive load? I would suspect it would be, because when you look at the numbers and the way they're going, the trend would be to get down there. But the question
I can't explain why your results are working out, but I know that if you take a transformer and you introduce more turns, like a second secondary turn, you're changing the conditions of that transformer. And so by you passively putting in a resistor, when I swept my filters, I don't even think I put a 1500 ohm resistor in. I just use my spectrum analyzer, right? And I use that, knowing that I'm loading it down to 50 ohms, right? So it's very, very difficult to make these measurements with a 50 ohm device.
This is what you end up with.
It's very, very difficult.
I mean, this is where, look at this one. This is where you're just hooking up the SA right directly to it.
But Peter, also too, look at the peak. What's the I don't know what the term is, but if you look at the peak to the skirt, to the bottom, because this peak looks very broad. It looks as if the Q, it's the crystal filter has been loaded down tremendously. So it looks as if the Q is flattened out.
It has, because it's a 50 ohm. It's the 50 ohms from the spectrum analyzer that's loading this down.
Yeah, but it's a 200 ohm. It's a 200 ohm.
No. This is a direct connection to the spectrum analyzer.
Right, but if the crystal filter, well, no, I guess if the crystal filter is 200 ohms and you're putting a 50 ohm end to it, I guess that's like a short circuit, right?
Yeah.
But should that broaden the Q? Would that broaden the Q? I think it would bring it down, but would it open the skirts out?
If you increase the resistance, it's going to change your Q. It's going to lower your Q and make your bandwidth wider, and it's going to drop the amplitude.
That's correct. If you add resistance, it broadens it. If you take away resistance, the peak gets sharper.
See this here? On this screen here, I added some resistance to parallel the 612 load. This part here within the red circle did not change, but these skirts did come up like this. They came. I'm exaggerating, but they came up on both sides. They rose up, which is what you expect, right?
Yeah. So, but anyway, my battery, I'm at 5% here, so my battery's going to die. But I just wanted to say that you have to be very careful in terms of adding turns to a transformer in the circuit, because you're changing the characteristics of how that transformer performs, because the transformer has one primary, one secondary, and now you're introducing a secondary winding to the transformer. So you're changing how the ratios are going to be. Does that make sense?
Yeah, oh yeah, of course it does. And this is why I'm saying, like right here, it's showing that, you know what, if you're looking at profile and all those kinds of things, your load isn't critical. If you want to make an absolute measurement, as we've discussed before in other areas, yeah, now the debate happens. So in this case here, which is the more accurate measurement in the case of absolute values? I don't know.
No, but no, you can't. You couldn't make an absolute measurement here. The only, but the fact that, as Ken said, you changed the resistance, you changed the Q of that filter, and all of a sudden your profile is going to get sharper or it's going to get wider, right?
If you look here, you can see the difference between the one-turn method or just the load resistor method, and the profiles are pretty much bang on. The only thing that's varying is the amplitude. So,
well, and I would say, Peter, either method is loading that crystal filter down.
yes,
They're both not a good method, I would say.
I think what I'm taking out of this, it doesn't matter which way you go. For our purposes, what you're doing is
absolutely 100%.
Yeah,
100%, Peter. I agree, and that was going to be my final comment. Is that for at our level of making measurements and doing things, this is good enough.
Absolutely. And you know what? Up until I did this, it was only a theoretical discussion between us because we didn't really know what the difference was between the two. Now we do.
Does the degree of, like, if you wrap a turn around through the toroid, there's sort of a degree of magnetic coupling that's in there somehow?
There will be a loading effect.
Like if your one turn was tight, if your one turn was tightly wound,
any turn in there, I mean, one turn doesn't sound like much, but today's point, and he's right. I mean, this goes way back to my electrical theory from many years ago in the 70s. You know, putting another turn on something or adding another winding on a transformer is going to load it down or add some load to it.
Yeah.
It just becomes a question.
One other question.
In my mind, it becomes a question: what is the more accurate way to depict what's going on? And both have issues.
Another question: the four peaks on the crystal filter, is that? Yeah, let's say 1, 2, and 3 on this diagram.
Yeah, I only simplified down
to
here.
That's analogous to what we.
Sorry.
Is that because the various peaks here? Is that because the crystals aren't matched, like we did with the LBS project, and we found that if the crystals weren't matched, you get waves like, instead of very very peaky thing, a single peak.
That's an interesting.
Is that what's going on?
That's an interesting question, and one thing I did was I changed the orientation of the crystals to see if the peaks would follow. In other words, I assumed that this was a particular, this was the peak on the input side of the crystal filter. This was the next one in line, and then over here, the next one and the next one, because I have 4 crystals. So what I did was Dave talked
at the time we were doing that, he talked about modifying the filter characteristics, I think by tuning the capacitors somehow to get a sharp peak, if I remember correctly. That's what Dave was doing with the software.
That's the way I think you have to do it, because when I took this crystal out of this position, one closest to the tracking generator side, and I moved it over, I can't remember if I moved it over to here. I probably moved it over to this side, and the ones that are over here, I moved over to there, expecting to see maybe the flatter side over here and the humps over here. And that didn't happen. The profile of this filter looked the same. So that goes to the point of the ripple that you're seeing is changed by those capacitors and not because of the, well, I guess there is a mismatch of the crystals that cause it, but they seem to work together to the point where the orientation doesn't matter. I'm not sure if I worded that all right, but that makes sense.
Yeah, I guess so. I was just thinking. I know.
Yeah, let's put it this way. I went into this thinking that the peaks that I saw were in order of the crystal filter. When I changed the orientation or the order of those crystals, the profile of the filter did not change. So something else is going on, right?
Yeah, maybe somehow each of the
the profile of the filter
crystals are different. So
if that makes sense.
Hey, Peter, I'm looking at this on my phone, so I can't see numbers.
Yeah.
All I'm seeing is a line, a green line. What's the, from that cursor point there to the top, the second point, what's the difference in dB between the two? How big is that hump?
That's about 7 dB, but that's also a 3 dB. Like the first cursor is the 3 dB point.
No, the middle point.
Yeah.
How from there to the end, you've only got 7 dB of like attenuation between the peak and the skirts.
That's probably not the right one to look at because I'm measuring the bandwidth here, Dave. So the cursor 3 and 1 are not on the peaks.
No, but I'm just looking, I'm just wondering how high is that, like the Q, I'm looking at how steep, because according to that, your filters, you've got about 7 dB, like, I know we can't make an absolute measurement, but you've got of the order about 10-ish dB of attenuation between the top and the bottom of the filter. That seems kind of low for a crystal filter, isn't it?
This one here be a little bit more. This is a better one to look at. So number 2, the one in the middle here, is at 25.7. At position 1, you're at 29.1. So 3 dB roughly.
Sorry, it's how much?
About 3 dB difference between position 2 and position 1.
No, between the bottom, the top and the bottom.
Oh, you mean down here?
Yeah.
You mean?
Okay, down here is around 55, 56, 57 dB, minus 57, 56 dB. And up there you're at 25.
25.
26 almost.
So you've got about 25 dB of attenuation between the top and the bottom.
Yeah.
Okay, that seems. I don't know if anyone else has got experience with crystal filters. Is that about right?
I don't know. I see what you're saying, Dave. Like, how low are we going here? Yeah. Yeah, we're at 56. So yeah, you're on 25 dB roughly, give or take. You expected more, Dave?
Yeah, I'm gonna have to go soon here, but no, I just wanted to know how steep, because the top to the side is going to tell you how efficient that filter is, right? So if it's 25 dB, I think, I don't have my filter in front of me. I don't know if that's a good, but it seems reasonable to have 25 dB of attenuation, right?
Now, see here,
This
when I look at
got about 35.
Like when you look at the 1.5K load scan, I'm showing an even greater difference, because here you're just around minus 70, 71, 72 dB.
About 35.
Here at number 2 in this particular scan is minus 38. So 38, 48, 58, 68. So you're over 30 dB in this particular case. So there's the difference with the loading effect on the skirts. And then in the previous slide, when I added some resistance to the scan, the skirts raised. The profile of the filter did not change, but the skirts, when you added resistance, raised the floor level, if you will, of it.
And Peter, last question. I'm gonna have to go now. But what's the bandwidth you measured for this?
About 3K. Yeah, 3K.
It looks like the attenuation is 20 dB per kilohertz, based on what I'm seeing on the screen here. And if your bandwidth is 3K, yeah, that's kind of 60 dB per. So it's a third order filter, right?
4.
Fourth? Okay. So, yeah, that's roughly.
Now, in this case here, I want to put in there, but there's actually 4. There's 4 crystals in there, Hassan.
Oh, so it should be fourth order or something like that, or eighth order actually, because each crystal is like LC. So yeah, it's not very optimal. It could go a lot better, I think.
That's the next generation Phoenix receiver.
Yeah.
Yeah.
Okay.
So Peter,
yeah,
the 3 delta 1 marking on the previous plot. That's the difference. Yeah, this one. That's the difference in frequency between 3 and 1, isn't it? That's what that means?
Yes.
Okay. Okay.
Any other questions or comments? Yeah, so I guess in the end is, whatever method you choose to go is probably not going to make a huge difference. Just as we were just talking about now, though, getting the resistance wrong or something like that could actually mislead a little bit, I suppose, on how much it's cutting off. Like I say, in this case here, it's showing around minus 60. But like I showed in the previous slide, when I added some additional resistance to it, the noise floor did come up. Okay.
Peter, it'd be really neat if you could. Would you be able to send me that presentation so I can take another look at it and sort of understand it better?
Yeah, sure. Yeah, no problem. Cherry.
How many spectrum analyzers you have got? Like 2 or?
I could barely afford one.
Yeah, me too.
I only bought one because I walked down Dayton thinking I'm going to spend my kids' inheritance because I deserve it. They don't.
Exactly.
And I went and I bought it. and then funny enough, is Dave still here?
No.
So when we left the Siglant booth and we're walking down, the rest of the flea market at Dayton, Dave's budget was for a spectrum analyzer was what he had was exactly in Canadian dollars is what he had is what they wanted in US dollars. So the exchange rate pushed the spectrum analyzer out of Dave's budget. So we probably left the booth and we probably got maybe 5 minutes away from the Siglant booth. And Dave says, "Come on, we're going back." And I said, "What do you mean we're going back?" He says, "I'm going to go buy the spectrum analyzer." I said, "I thought you said it was out of your budget." He says, "I don't care." He says, "I can't bear the thought of you being able to make measurements that I can't make." And I'll figure out the budget problems later.
That's sort of why I bought my spectrum analyzer, because I couldn't stand the thought. That's why I went to the 200 megahertz scope.
There you go. We don't even have a boat here. We're already playing footitis with this hobby too, right?
And I sold my linear amplifier, which I got $500 for, and I used much to Margot's disappointment. I used most of that money to buy the signal generator, signal generator, and I argued, well, that was a long time ago, and that's okay. They can work that way. But anyway, that's how I justified it.
It's interesting. I mean, when I bought actually, I was actually going to go down the path of homebrewing a spectrum analyzer, and I sat down 4 days in May with Farhan, and he went up to his room and he brought down his homebrew spectrum analyzer. I guess you call it more of a measurement receiver, but anyway, he went over it in detail on what he did and why. And I thought, okay, I'm going to build one myself. And then somewhere along the way, I thought, you know what? I'm going to spend the kids. That was my new motto going into the next Dayton trip was I'm going to spend my kids' inheritance. And instead of building the spectrum analyzer, I went and bought one. And then about a year or so after that, or maybe a couple of years, I can't remember now, the Tiny SA came out. Well, the VNA came out, the Tiny VNA or whatever they called it. And then the Tiny SA came out shortly after that. So I think if it had come out first, I probably would have gone with the Tiny SA. I don't know. Now, actually, having said that, Michael, I think you got something coming up in the new year later on.
Well, I have I bought the Nano VNA first, and then I went and bought the Tiny SA, and then I went and spent the $1,900 on the spectrum analyzer. The real spectrum is better than the Tiny SA. That's why I did it.
Yeah, it'll be
I haven't
interesting.
actually got around to doing anything with the Tiny SA yet. I've got plans. I'm going to have a look at it, learn how to use it, and then I'll put a little presentation together and show it.
Yeah, it'll be interesting because I had a conversation today with another ham actually, about the Tiny SAs, and I said, well, hold on, because we have a presentation coming up later this year. We can make some comparisons.
They've come out with the 4-inch, the equivalent of the H4 with the 4-inch screen with the Tiny SA, but I can't just. Why would I do that? Why would I, replace?
No, not that you got the spectrum analyzer. Yeah.
Besides, I've got a hard case with foam insulation. Daniel and I bought these things, and we've got all our test instruments in them. And if I go buy it, I got no place to put it because it wouldn't fit in the case.
You need a bigger shack.
Not enough space. Hey?
You need a bigger shack. You have no place to put it.
I mean, really, if
Especially
you like get a bigger screen for your Tiny SA.
Look at the size of that guy's workshop. Holy cow.
If you want a bigger screen for your Tiny SA, just put it under your USB microscope, and then you got a nice 7-inch display.
Oh,
right.
What USB microscope?
Yeah.
Now there's somebody thinking.
Yeah.
And your microphone's working, I see. Okay, good.
Yep. Sorry to say.
Are you going to be able to do your presentation?
I am.
Perfect.
It was a highly technical problem.
Oh, okay. You forgot to plug it in. Okay.
No. I don't have any of that fancy stuff here. No, there's this big wad of gum right in the center of. No. The stupid keyboard switch was off, so I don't know.
All right. Okay. Well, before we move on, then, has anybody else got any other comments on so far? Okay, great. All right. Well, Eric, if you're almost set to go.
Yeah, I should be good here.
I'm just going to go grab, because I've talked so much, I'm dry. I have to get something to wash that down.
Okay, let me see if I can share my screen here. And I apologize for the recording. For about half of Peter's presentation, I could not get the toolbars to disappear on the screen, so the recording is going to have a nasty toolbar covering some of your slides, Peter. So, all right. Okay, hopefully everybody can see that.
It's a black screen.
Say it isn't so.
It's a black screen.
Not where I'm looking at.
Oh, there it is.
Yeah?
Yeah, success.
What about now?
It's black.
Yeah, it's there.
Who sees it?
There.
I see it.
I see it.
Yep.
Very
I can see
decorative.
it.
Okay.
Yeah, I see it as well.
All right. So this is going to be much more simple presentation than as far as from a technical point of view, from what Peter was going through with his measurements there. But nonetheless, I think kind of interesting topics. I was looking at the last time I did one of my little, I think, component corner, or whatever I called it. It was like 20 months ago when I was talking about resistor. I can't believe it was that long, the resistor talk. But anyway, time flies. So tonight, not going to be talking too long about this, but just a little bit about crystals, some things that I've come across with it. So talking about, and again, this is not radio related particularly, again, more talking about components themselves, and perhaps there's going to be some things that can be, whatever what the term is, crossover learnings that can be transferred to other projects. So 32 kilohertz quartz crystals. First question begs is why 32 kilohertz? Why is that such a common thing for watches? And as you can see, we've got a inside of a watch there. So move on to the next slide. Hopefully, did that change? We're seeing a different,
yeah. There you go.
different slide. Okay, there's a little bit of a lag. All right, so basically, deep within that quartz wristwatch, you can see it, that red arrow. There's a tiny tuning fork that's inside that hard metal case, and or the metal tube, really, and that's cut from quartz crystal and keeps the watch running on time. It's in a tuning fork shape. So it's plated with mirror-like electrodes on its surfaces. So like in music, you got a tuning fork, you cut it to ring at, A 440 hertz. Resonant frequency of this particular tuning fork in watches is beyond the range of human hearing. So my question is why did they select 32 kilohertz? It's, to be precise, 32.768 kilohertz. And it's interesting, the reason why. Also, if you look at the top of the tuning fork where the blue arrow is, you see little scratches. It almost looks like a manufacturing defect, but what those are actually are laser trim marks, process that fine tunes the frequency to get it exactly to 32,768 hertz. So frequency that the crystal oscillates depends on its shape, size, and the plane on which the quartz is cut. And in fact, actually a few buildathons ago at Hamvention, or actually FDIM, I should say, we were doing just that. We had crystal blanks, and there was some cutting and polishing and all that to get the crystals tuned to the specific frequency. So anyway, the positions at which those electrodes are placed can slightly change the tuning as well. So when everything is exactly shaped positions, it'll oscillate at that desired frequency. So neat thing about quartz, as we all know, it's piezoelectric. It flexes ever so slightly when a voltage is applied to it and produces a voltage when it's flexed on the opposite. So basically inside the watch, tiny voltage is applied to electrodes, the quartz flexes and then rings at its frequency. So produces that oscillating voltage. Every second, digital circuit counts out the 32,768 oscillations, then drives the second hand forward a single tick. So my question is then, how does the circuitry do this? Well, frequency divider. So also, why 32 kilohertz? Well, it's not in the audio range. Basically, it's the limit as to what you could hear, a human ear with the best hearing. So you're not going to be hearing a buzzing or a humming watch. Basically, that's part of the reason why they choose that. And pretty much all crystal controlled quartz watches use that frequency. Also, that frequency is a power of 2, so it's 2 to the 15th power, and it's just low enough as well to permit inexpensive counters to drive that 1 second pulse. And it does that with the frequency divider. So there's a 15-bit binary digital counter driven by the frequency, and it overflows once per second, creating that digital pulse. And it also keeps the energy consumption low. The size is modest, and it's cheap. So anyway, that was kind of it. Just what are the next things that I can go from here? What are the next projects based on this? Measuring those crystal frequencies with a scope directly, just to verify and see what if there are any variations. It'd also be interesting to see what it would take to build a flip-flop circuit. I came across a few interesting designs where you can just tie a bunch of passives together and see what happens. So, and see if you can actually make the divider circuit itself that was shown on that previous screen. So anyway, that was about it. Quick and dirty, I guess. And thanks for listening.
Eric, it's interesting playing with the flip-flops and divider circuits and stuff, because I did do a project where I wanted to read the frequency. And so I had to start experimenting around with flip-flops and, Schmidt triggers as well, et cetera, et cetera, et cetera. But it was kind of interesting to play with the different divide functions of a chip, and then seeing how it responds. Well, in this case, the Arduino, and how which is a better, how far do you have to divide to make an accurate measurement? And when you mentioned there about so you don't hear the buzzing on your watch, I kept thinking, I wondering if that would zero beat with my tinnitus if they didn't have the right one. But anyway,
it'd be a good secondary benefit. Find where that sweet spot is, but.
Yeah, maybe if it's the opposite phasing, maybe I could cancel my tendonitis. Oh, there's an idea.
Hey, there you go. That'll be the
put that on my list for
question.
Project.
Next project. I'm not even sure actually. Flip-flops, is it op amps that do that, or is it transistors, or can it be either?
For what?
Sure. To make a flip-flop.
Whatever you want, transistors, sure.
Yeah.
You use whatever you want. It just depends, right?
Mm. So anyway, that was sort of my little bit of stimulation, I guess. Figure out what to do next on the bench once I get my study books off the bench. That's about all that's there right now. So, okay, I think we're back to the meeting.
Okay. Well, thanks,
Hopefully
Eric.
the sharing is off, right?
Any comments, anybody, on flip-flops, divider circuits? Okay. Anybody have any comments, questions on their minds on anything? Great. This is going quick now. Okay, well then let's start off with our usual mixer item. What's on our bench. So since I'm on the top left of my screen, I'll go first, and I'll just quickly share a screen on this. We can see that?
Yeah, I can see it.
Okay, so on my bench, with the, as you know, Dave and I are working on the Phoenix transceiver, and my portion is the receiver transceiver, and got to the point where I got it working, but I wasn't really happy with it, and I wasn't really 100% sure where the problem was. And I started to suspect that the audio amplifier was an issue. There might be other issues, but I think the biggest issue at this particular time was the audio amplifier. And for comparison, and what I'm showing on the screen now is the original Dueling 612 audio amplifier, which we ported over to the Phoenix project. And to test the difference, I used some powered computer speakers I had, and it worked much better. So Dave put the pressure on me and says we need to get this moving, because we may want to take a sample, a working model down to 4 days in May to show off and whatnot. So I really had to get this audio amplifier figured out before I went to Florida, because I can't take my whole shop down there with me. And so I thought I'd better come up with another circuit. So the suggestion was this one here, and well, let's go back here. So here, really, we're using a 3904 as your preamp, and then we're going into an LM386. And that's it. Basic circuit, no big deal. From a mechanical perspective, these output jack here and the input jack here I had on hand. I had a footprint in KiCad for it, so away we went. Didn't measure it right. installed it, didn't work, put jumpers in, and then of course when you start doing all that kind of crap, anyway, between the circuit not being good enough and then the mechanical part issues there, it was a real nightmare to get this thing going. So we switched to this circuit, and this circuit actually was from Pete Giuliano from his Simple Siever project. Now we did make some changes here. We changed the value of this capacitor here. I don't have my other sheet here. I think this used to be 10 nanofarads. We went to 68. I forget what C6 was, but we switched to 0.22 excuse me, microfarads on this one. The other changes we did was in this particular case, I added another decoupling capacitor here in addition to the 100 microfarad capacitor, which was Pete's original design. And again, same to the original design of 100 microfarad capacitors. And the other one was Pete used a 5534, I think it was, which is the same as op amp as this one, except it only has one op amp in the package. This particular one I had on hand, the 5532, has two in the package, but I only used one. This amplifier worked great. It really brought the Phoenix receiver to life. I was able to easily copy S4 sideband. I was listening to Trans Provincial Net. The signals at that particular time I was listening were dipping down to about 0.3, down to about an S3, and it was still easily armchair copy. So we were quite pleased with the results of that. And I'm now able to go to Florida and relax, and all I've got to do is document it. So there we go. So that's that's all that's been on my bench for the last little while. So I said to Dave, "It's working. It's great. I like it. We'll go with it." And then Dave says, "Nice job. Now document it and update the schematic and send it off." So no rest for the wicked. Okay, up next on my screen here for on the bench is Eric.
All right, there's the mic. Well, the only thing that's really on my bench right now is the Canadian Amateur Radio Basic Qualification Study Guide. So two sessions in so far, and all systems go. So actually, it's really good. This is the most sort of in-depth course. The presenter is really good. What's really bad are the students in the course. The chat window on the side, just full of inane questions and whatever. And I'm not saying that because I know a few things about it already, but just the banter that goes on is poor presenter, man. He's really good. Al Penny, I think his last name is, from Nova Scotia, the Annapolis Valley Club. But he's got lots of experience, just the right amount of anecdotes and personal things, and I've learned a lot of things already. The little minutiae, like fine details from even the first couple chapters. Basic electricity and what have you. Some interesting factoids. So, like, what was the thing that I never realized? I know dB, right? When it goes up by 3, it doubles, right? But did you know that wire gauge follows basically the same thing? When a gauge of a wire goes from 9 to 12 or whatever, you're, I guess halving the diameter of the wire. So that's how the nomenclature works.
So it sounds like by the time I get to 4 days of May, you're going to be unbearable.
I'm going to be the Cliff Clavin of ham radio. You got it. So.
I'm glad you're doing that. That's great. You're going to have to keep us on toes, and you're going to have to start asking Dave. It's too bad Dave isn't here to hear that you're going, because it must mean he's going to start sweating, that he's going to have to start learning Morse code. Good for you, Eric.
So also, I've just booked accommodations for Hamcation for next week. So going down to that for the first time. That's not this weekend, but next weekend, Friday, Saturday, Sunday in sunny Orlando, Florida, where temperatures are 25 to 30 degrees and sunny right now.
Better take off my shirt.
Yeah. Anyway, so yeah, that should be fun. Driving down, so a long trip, but is what it is.
Lucky you.
Sorry?
Lucky you.
Lucky me, yeah. And well, a little bit of treat, but also it's going to spend 2 or 3 days visiting a cousin about 4 hours north in Tallahassee that I haven't seen in years. So that's that was a clincher for going on this trip. But I don't know, heard lots of good things about Hamcation. It's basically a mini hamvention. So,
well, I'm really looking forward to it because I'm gonna be meeting Eric down there as well on Friday, and we've got the Airbnb there, so that'll be good. And we're going to meet Rick VE3ORY. He doesn't come to our meetings here very often, but Rick's another Kingston ham, and I forget who he's going with. Anyway, we're going to meet up with him on the Saturday somewhere around Hamcation. And I just got a message from Bob, and Bob is going to Hamcation, so we'll meet up with him as well. And we're going to meet up with Mike at some point. So it's going to be like a little bit of a family reunion down there. That'll be great.
Yeah, absolutely.
Okay.
And last thing, second last thing? Yeah, no, last thing.
Good.
The poll from the last meeting or whenever it was about the visit to the Hammond Museum of Radio. It looks like Wednesday, March the 1st is the day that we'll be going, approximately 1 p.m. I need to confirm that with the museum staff, but that sounds like what we're going to be doing. So
March the 1st, don't forget, you better be back in time because you're the one that's conducting the mixer.
Right. Yep. Yeah, should be fine. So
Okay.
that's it.
Okay, thanks, Eric. Al, what's happening in your neck of the woods?
So just found the mute button. Oh, work. Work is a 4-letter word, don't you think? Anyhow, it's been keeping me busy.
Don't ruin my retirement by mentioning the word work.
My turn's coming someday, I guess. Yeah, I'm old enough. Anyhow, not too much on the shack this month. Life has been busy, but I did find time to finish up my latest regenerative receiver.
Oh, good.
Rabbit hole. I think last month I showed you the one out of the Sprat magazine that I built, an 80 meter, and the latest one is. You've probably seen publications of this in the ARL. This is the Dan Whistle WBR Wheatstone Bridge regenerative. So I just finished that up. You can buy a printed circuit board from Far Circuits. Is that in focus? Well, sort of.
More or less.
Yeah, it's not here, but anyhow, and you populate it. I'm quite impressed. It's rock solid, loud signals, fantastic. The one thing I like is I've gone away, or this design's gone away from tuning with a variable capacitor to a 10-turn potentiometer and a varicap. So it's much easier to tune, much more stable. Mm-hmm. So the only thing I have left to do is try to get the pickup coil to run it into my frequency counter. I installed it and it pulled the input circuitry enough that the signal strength went down. So I pulled it back off, and now I got to go looking through the circuit to see if there's another place that I can tap into it. But anyhow, quite successful. Who knows? Maybe you want to consider that as a buildathon someday. The printed circuit board was only about $5 from Far Circuits, so it might be worth taking a look at. So anyhow, that's the latest edition. And then after that, I'm not sure what I'm going to do next month. I've got a shelf full of half-baked, unstarted, and unfinished projects that I got to start getting onto these things. They're kind of growing, if you know what I mean.
Well, it's interesting because when I first started, when Frank got me addicted to homebrewing, I had a discussion with another ham, Hugh, VA3TO, and we were talking about projects and things like that. And he mentioned how he had a bunch of unfinished projects sitting in a drawer in his shack. And I said, how could that be? He said, you buy a kit, you build a kit, you design a kit, you build, how could you have something that's unfinished? And he says, just wait. and he's right. You got all this stuff that's in there you buy and you're ready to build it, and it just somehow gets missed. But
And then there are those that don't work as planned. You
Uh,
fiddle with them for a while, and then decide to park them for a while and come back later. So,
and then there's some projects where you spend so much time on them, and then you finally finished it, and you have no further use for it. But because of all the time that was invested into it, you can't take it apart.
Mm-hmm. Absolutely.
So anyway, I'll leave it to the kids to take apart.
Right.
And you mentioned the using the pot with a Varactor.
Yeah.
And I remember doing some experiments with using a regular diode and messing around with that to swing the frequency.
I understand it works.
And I think I did. I know I did a presentation on it. Whether I actually did the presentation, but I think I know I developed it. Maybe I should dust it off. You know what? Maybe some of these presentations we've done 3 or 4 years ago, we could redo them again. Anyway, especially if nobody remembers them. Okay, thanks for that, Al. And you know what? Actually, thinking of actually one other comment I have here. You've got a couple of interesting projects on the go there, those regens. And maybe when we have, and of course, we've got the the DCR that'll be coming up soon. And of course, the Phoenix project. The next time we have one of our one weekends at wherever's, we all get together, we could bring these projects out there and power them up and make comparisons, look at them and, give them the workout. It'd be most interesting to see this stuff that we've been talking about on these, what's on our benches.
Sure, I'm in.
Yeah, I'm in too. Okay, Cherry, what's on your bench today? Oh, this past month.
Before I get into that, I just wanted to check, Al, what board is that? What you've shown just now?
The board or the project?
Yeah, the project, sorry.
The project is called the WBR.
Okay.
Stands for Wheatstone Bridge Regenerative.
Oh, I see.
The author's using the Wheatstone Bridge as the input circuitry, and it makes it sensitive and reduces the amount of oscillator radiation back out the antenna, which is a common thing with regeneratives. You'll see it was published in QST, and it's found its way into a number of ARL best of republications. The author is Dan Wissel, Wissel.
Okay.
So it's commonly available, and he built it with dead bug construction. But Far Circuits has a printed circuit board that's quite inexpensive.
Of course, you could reverse engineer it and go to JLCP and get that 7 of them for $5. Oh no, sorry, it's 5 for 9.
Thanks.
Anyway.
It's all through hole construction, so okay. Who knows? Maybe somebody on KiCad would like to make a surface mount version of it. But Cherry, if you want to inspect it and play with it and see whether you'd like to make one, by all means, you're welcome to borrow it.
Okay, thanks. Thank you. Good. Okay, so I will start. So on my bench, I have a few books which I'm reading right now, and I was working with this thing for an NFED. It's just sitting there. I completed Winding long time back, but I want to finish it pretty soon. I'm also looking at some of the common mode chalks. So I've been seeing a lot of YouTube videos on it, on the common mode chalks, which I'm pretty interested in to do now. The one thing I'm facing is one problem that I'm facing is I'm not able to get the the kind of Teflon cables I want from any store here. So I think that's something which I might have to do when I'm in the US to get the gauge I'm looking for, because for the 18 AWG or the American wire gauge is quite hard to find here with the Teflon kind of wire, which I want to use it on the common mode choke. Some of the videos I have seen suggesting to use Teflon wires on those 240-43 ferrites, which will actually bear with the heat. Yeah, go ahead.
Amazon's got Teflon wire.
Either they got the full reel, which is like $100 or $300. They don't have like a smaller, probably something called loose parts. they don't sell like that. That's what I saw. But Amazon sells. All the major component vendors are selling it, but unfortunately, those are coming in bigger reels, which is like $300 and things like that. So
Yeah, you should really look hard, because I bought, I think it was 14 gauge Teflon. I think two loops, 20 feet, red and black.
My experience with Teflon cable is minimal, and I never want to touch one again, because to try and strip it was a nightmare. Now, I don't know if it was just a particular type of Teflon cable I was using, or it's all Teflon cables. But anyway.
Yeah, I had very good experience with it, and like I had some wires which I used in the past to make connections in the circuit and so on. So it doesn't melt. That's what I like, because when you solder it, it holds good. It doesn't melt. Got good conductivity. Like it's just good. I've been lucky to find some of the 16 and I think 14 gauge, which I found from A1 Parts. There is a store in Mississauga. I think it's in Mississauga. Yeah. So
gauge is going to take a lot of power. So,
yeah. No,
I mean,
I don't need it, but I just bought it when I saw it, because I just want to keep it for my future projects in case anything comes up, because these wires are not very easy to get here.
Yeah.
So, the one that I wanted was 18, and I couldn't find in that store. A1 Parts, you might know. Like,
did you try an electrical wholesaler? Like electric or?
Yeah, that's something I wanted to ask in this meeting. Actually, I saw a couple of them, but they sell only B2B, like business to business, right? So,
I see.
Probably those electrical wholesalers might have it, but I'm not sure which one I tried. I saw a lot of them when I Googled, but a couple of them are like business to business. But I should try one of them.
You know what? I think if you went in there now, whether or not you get a small amount, that's a whole different thing. You might have to buy an amount that would keep you about 10 lifetimes of.
Yeah, I think so. Yeah.
Well,
yeah.
Okay.
And I found good source in eBay, which I'm probably might try. But these are pretty expensive. Yeah, that's for sure.
Well, if we see any down in Hamcation, what size you need? Number 18. How many feet do you need? 2 feet?
Just buy maybe 10 feet of that. Yeah.
Okay.
Yeah.
Well, we'll keep that in mind.
Thanks. Thank you.
Okay.
And a couple of books I'm reading right now is one of this is.
Okay.
Yeah. This is by Joe Carr, Joseph J. Carr.
Good guy.
I like this author very much, because the very first book I bought about antennas is actually from that author. I was just I'm not sure where I kept it, but the very first author I had in my book collection back in '96 I bought is from Joseph J. Carr, and ever since I have it here. So ever since I like that author very much. So whenever I see this guy's book somewhere in some Hamfest, I just pick it up.
Yeah.
So
this is
the very first book I bought on Antenna Handbook, which is from Joe Carr. Yeah, it's written here. Yeah.
Okay, that's great. Thank you.
Yeah,
you mentioned with some books you're reading. The latest one I've been reading was this one, RF Design Basics by John Fielding, and because I'm working on a presentation on receiver circuits, and I'm really getting into. I'm really paying attention to what I'm reading. Let me put it to you this way. So I sent him off an email asking him a question of what he said, a statement he made in there, but he never replied back. And actually, you know what? That's the first time I've sent an email or a message off to another ham about something, and I never got a reply back. I've always been amazed that I get replies back from everybody except for this guy. But anyways, it's a good book. Okay, thanks for that, Cherry. Drew, you must have something on your bench.
Well, I do. but it's not really radio related.
Okay, well then we'll go on to who's next on my list. Go ahead, Drew. I'm sorry.
No, I'm playing around with Arduinos. And
that's relatable.
Well, it is. And the thing is that I've seen a lot done with them. And so to learn about them, I have to have something to do with them. And as a kind of a side interest of mine, I've gotten to know a few local little movie makers. And these are people who produce, I'm not sure what grade is below grade B, but stuff that would never make it on a drive-in. And eh? Wait, they no, not at all. This is science fiction, Doctor Who stuff.
Okay. Oh, good.
And they're kind of geeky characters. Anyway, so he came to me once and he wanted an asteroid. So I built him a paper mache asteroid with a bunch of lights and stuff in it. He's very thrilled, and off it went. And that's fine. Now he wants a fake spaceship cockpit. And I thought, well, Arduinos can do a lot of stuff. Let us see what we can do with them. And that's been how I've been exploring and learning about how Arduinos work.
Oh.
And, when you have something to do, you'll learn fast. So, programming is programming, but the language finesse is important. And so as I'm going through that, I'm remembering a lot of the stuff I did, back when punch cards were in vogue. And I'm kind of glad to see that it's not all lost. That despite the some of the nomenclature, I bought it before that was the thing. So it's one of these B&W antennas I've talked about before. And actually, it turns out it's nothing more than a 9-to-1 unon and a random length, and then a termination resistor at the other end. And so if it's a 9-to-1, and you put a 500 ohm at the other end of 102 feet of wire, or 105 feet, doesn't matter. And then you join the grounds together between the termination resistor and the balance and the unon. You create this terminated end-fed V, which is what I have been using. And this is my backup plan, is to build one of these things. I'm kind of excited about being able to create it because it's a very wide band antenna. It tunes 160 to 10. Actually, to 6.
All right. Is it in service?
Not yet. One of the things I wanted to bring up here, the termination resistor, of course, there's been some discussions on the various interwebs about thick film resistors for this kind of application. And I was wondering about, normally you'd use a carbon, but they're, the end, because the distribution of energy across this thing is pretty uniform, you have to have a fairly good heat or dissipation, wattage dissipation at that end. So I was looking at these thick film resistors, and I can get a 470 ohm, 100 watt thick film resistor for $20-$30, which is quite cheap compared to buying one of these antennas from somewhere. And I just wondered if anybody had any experience using thick film resistors in antenna applications.
No, it doesn't look like it.
Doesn't look like it, no. Okay, well, then I guess I will report back to the group if and when I continue this project.
That'll be good.
Which I will be doing. Anyway.
Funny you mentioned the thick film resistors. I was just reading an article not too long ago on the advantages of them, and I can't remember what I read.
Well, it seems to be power dissipation is one of the things.
Yeah.
And I was thinking, well, carbon resistor, a carbon resistor is one thing, but they're fragile.
Yeah.
And I was thinking the case these things come in, I can actually put a heatsink on it.
Well, I think where I was coming from with the thick film was I think it was a capacitance / inductance / I don't know, I can't even remember now, was minimized on those type of resistors.
Which would be perfect because I want none of that at the end of an antenna.
That's right.
Anyway, so that's what I've been up to, and droning on as it was, but that's the way it is.
All right, thanks, Drew.
Enjoy your trip to Florida.
I will. Hopefully, we'll be catch you guys on the air on one of the Mondays.
Yeah, absolutely.
Okay, Frank, you're up next there. What have you been up to down there? You're still muted. Frank, we've been doing this for 2.5 years now, and you still can't find that mute button.
I don't know what.
Yeah, you're good now.
Okay. Every time I do it, it's different. Anyway, I'm still working on my direct conversion receiver. Excuse me, using the glue stick.
Oh, right.
There's a lot of parts to it. So you can see.
Frank, Bill Maher would be proud of you.
Yeah. It's all complete, but it's not working. What I'm using a 2 FETs instead of, and I've never used that circuit before, so I'm not
Frank,
too
can I
sure
just-
what to
Frank?
expect.
Frank, can I ask you a question?
Yeah.
It broke up there a little bit. You said you're using 2 FETs instead of.
Instead of the diode ring mixer.
Okay, most interested in that.
Yes, I thought that was going to be different, and it is, but I can't seem to get it to work. So I'm thinking about just dropping in a diode ring and troubleshoot the rest of the circuit to make sure everything else works, and maybe I'll come back to the dual FET type thing. The audio, interestingly enough, on this rig uses that 5532 that you spoke about earlier. And the output is supposed to be a lot better than a standard 386. So I'm looking forward to that, but I haven't got to testing that stage out because I got stuck at the mixer stage. So back to the drawing board, back to the workbench, and we'll see if we can't sort it all out by next month.
Oh, that's good, Frank. Well, that's it. You got some interesting stuff going on there. And I was actually amazed at the difference between a circuit that involves the 3904 going into the LM386 and that performance versus the what was the number I said? 33. I can't even remember the number of that particular op-amp and the LM380, and the difference was night and day. So actually, when I think about it, I don't even know where I got that chip from. I was surprised I even had it because Dave said he would mail me one if I needed it. And I thought, well, I'll double check and see if I have one. And sure enough, I did. But anyway, that's good. Okay, Frank, that's good. I look forward to hearing how you make out. And that's interesting with the mixer stuff, too, because I've been thinking about, okay, what do we do after the 612? Do you go to a TALO detector or as you're experimenting now with the FET there? Or you go to eBay and order 30 or 40 612s, and then there's your lifetime supply.
If they work.
Okay, Ken, you're up next. Speaking of the guy who just spoke up.
Yeah. First thing I want to say is, Bob, wake up. Yeah. No, not much going on. I'm into the same 4-letter word that Al has been into. It's all work and play, all work and no play. But actually, I've been working on the DCR, but not much. Haven't really had time. Yeah, I'm just testing it out now. I had a little problem. I think I got it fixed out. But anyways,
solder joints.
What's that?
Solder joints?
No. That regulator.
Okay.
El Cheapo regulator. Anyways, speaking about the 612, I was, we all know that the 8-pin dip is obsolete. And someone on one of the other groups announced that they just received notice that the SMD version now is end of life. So if you need some 612s, you better grab them while you can. And Diz has 5 for $5 US.
Ooh.
I was looking at the 8-pin dips on AliExpress, and oh my God, they're like $20 USD a piece.
Now, I think we need to come up with something else. What's wrong with the Talo detector? So, like, those cheaps are cheap.
Yeah, I know.
Anyway.
We'll just go with the diode ring mixer. Anyways, yeah, so that's pretty much all I've been doing, just work. And I'm hoping to have this DCR finalized on the weekend.
Okay, that's good news. Ken, look forward to hearing what you have to say about that. And then we'll get this DCR project put to bed so we can move on to the next greatest and best thing.
Yeah, definitely.
Okay. Kevin, welcome back. I don't see a burnt nose or anything like that.
No, I stayed out of trouble and just anyway, yeah.
Well, so yeah, no. There then, if you're going to stay out of trouble.
Well, officially, okay. This is being recorded for posterity, so of course I stayed out of trouble. Okay. This does end up on YouTube, I believe, right? So yes, everything was great. Anyway, yeah. So not much happening because of that. So been out of town. I'm just gonna say for the Teflon stuff. I mean, we use Teflon wire at work a lot, but I don't know where we get it. I have to check. But I mean, if you only need a couple of feet of it, I could probably get some scrap or something like that. But because we use 16, 18, and 14 gauge. But anyway, no. Otherwise, for me, nothing. I want to work on that DCR2 and get that working. And otherwise, that's it.
Just to go back on that, not too much on the Teflon, but my experience with the Teflon is minimal. But I just recall it's a nightmare to strip, and I was glad to not have to use it a whole much. Was that just a particular type I was using, or is that with all Teflon?
The ironic thing is it's really hard to strip, and we need it for the temperature, right? It's 200 C, but it's hard to strip, but it has no, it's not very tough. It takes almost nothing to damage the insulation, which is ironic because we put it inside something else to actually protect the insulation, because any kind of, a sharp edge or something like that will nick the insulation. So it's easy to cut the insulation. It's not easy to get it off the wire.
Oh, okay.
So, but yeah, you're right. It's a pain that way. The only thing tougher than Teflon is that cross-link or cross-link PVC stuff. That stuff's really tough. But anyway.
Anyway, that was my previous life, so I don't have to worry about it anymore anyway.
Exactly. You don't have to go to work like the rest of us.
I didn't even renew my license. Since I've been in Kingston, I didn't even renew my license. And funny enough, I hadn't thought about it until just actually yesterday I started to think about that. And I thought, did I make a mistake? No. Anyway.
Okay. I'm going to cut out too. I got a very early morning tomorrow, so I'm going to take off.
Okay, so, Kevin. Cheers.
Right, have a night.
Michael, how's things going down in your neck of the woods?
I've been playing around with Daniel V3NI, and I are building some antenna switches. I have I have a manual antenna switch that basically is a rotary switch that is 12 volt my tower to my relay to my antenna switch. And the object of what I do is automate this thing so that in my case, the 1000 MPs band decoder information, which is an ABCD type thing. And we bought a couple of BCD encoders and a bunch of relays, and you got Arduino and a display. And the idea is to make the display say automatic or manual, depending on what we want to do. And part of the motivation of this is that when we do FT8, when I do FT8 anyway, the radio frequency, I want to switch the antennas automatically to the extent I can. So this is sort of the motivation for this, and it's coming along, and it's got me into. We're still doing some. We've sort of got a breadboarded circuit here that works more or less. Appears to work, at least the automatic. Haven't connected to my antenna because I manual antenna switch down in the shack here, and I don't want to touch it because Bouvet Island is coming next week, and I don't want to risk anything. So I'm leaving my antenna at 137 degrees. I've shut down Windows updates so the computers don't get messed up, and this is what we're doing ourselves. So what we want to do is open up this switch box and mess things up. So anyway, but so that's got me into looking at this and learning a little bit about Arduino programming, which is I've never done any before. But Daniel wrote a it's a very simple program just to switch the display from one band to another. And the other thing I'm learning now is KiCad. Because when Ken put the DCR project together, I think it was you, Ken, you had a KiCad schematic diagram. So I've been learning how to do that. I got a couple of sort of test diagrams, and seems to work. So that's really what I've been up to. I don't think there's anything else. Not really, but so I've been fiddling around with this stuff, and we're figuring that what we're going to do is after Bouvet is over, then we'll be able to free to play with our antennas and stuff and see if we can make all this stuff work. We're going to put it in a nice box and integrate a manual and versus automatic switch, so you can the BCD decoder and all that stuff, and just switch your antennas manually. One of the things I've got antennas that well, my mini quad is 10 through 20. Is a 3-element beam, and my R7 is 10 through 40. I've got a hamstick, 30-meter hamstick pair that's up there, and I got a DXB that's also 30 and 40 meters and 80. So we want to be able to sort of make things work so you can switch. What we're going to do is I would set one antenna as the default, and when I've got options, the manual control would take care of those options. So that's the idea anyway. So, and the other thing, as I said earlier, eventually I'm going to get around to looking at the Tiny SA.
Okay.
And see what I can learn about that and figure out how to use it and do the comparison with the real spectrum analyzer. Yeah.
I think that would be a really good.
And I noticed Peter's reference, by the way, to the signal generator doing the two-tone stuff we were mentioning sometime a while. Yeah. I forget what it was a while ago. I noticed that reference, but I knew about that, but I hadn't really thought about using it. So anyway, that's what I'm up to.
Yeah. Speaking of the two-tone stuff, I bought some stuff to do a two-tone, set up a test device for that, and it's sitting in the drawer unbuilt, and it's been in there for about 5 years. But anyways, one of these days. Speaking of KiCad, I see KiCad is going to have version 7 coming out. It's ready to go, but it'd be, I think, another week before they actually release it. They're having some trouble with the packaging mumbo jumbo stuff. So we'll see what's going to go on with that one. What other comment was going to be? Oh, and your antenna project, the auto antenna switching stuff. That'll be an interesting project. It'll be interesting to see what you do for fail-safe stuff in there as well. But we'll worry about that when you get that all done. And it sounds like you're quite serious about making a contact with Bouvet Island there. And doesn't the Mississauga still have those big antennas on that commercial building that you guys mess around with?
Sorry, say again?
You mean
the club station?
Yeah.
At the club station, we've got some beams up there, I think, but I want to do it from here. I could go to the club station, but I haven't learned how to use flex radio, so there's no point in going over. I want to do it from here.
Yeah, I remember that
307 trees.
I remember that 40-meter beam antenna you guys had up there. Holy cow, that was quite something else.
Yeah. So, yeah, I'm figuring that it should be doable from here. There was a guy that went to, he's actually there now. He went to Crozet, which is number 3 on the DXCC list, and Bouvet's number 2. And one guy operating basically 30 and 20 CW, FT8 and CW, and I was able to work him on FT8, which is amazing.
Oh, good.
And the guys are going to Bouvet on a sailboat, and they landed yesterday. They arrived yesterday, the day before. They're actually on the island, which is a good thing. So we're getting there, and so it sounds like there's a good chance of working him, because they operated Maritime Mobile. One of the guys on the boat operated Maritime Mobile when they were maybe 200 miles or 150 miles or something from the island, and I was able to work him on CW, which I thought was pretty good. So with 100 watts, so that's promising.
Yes, it is, and a local interest of the Bouvet Island expedition. One of our local hams here, I forget his last name, but his first name's Caesar. The call sign escapes me at the moment. Anyway, he's from Kingston.
Oh yes,
and
LYC V3LYC. He's down there. Yep.
Yeah. So
that's right. I knew that. Yeah.
Interesting guy, Caesar. He gave a talk at the club there a couple of years back, and of his experiences of operating up in the northern Arctic. So, he's looking for polar bears over his shoulder. But anyway, yeah, expensive. I think those guys had to cough up. The participants had to cough up a little over 20 grand to start off with to go on that.
25,000 each.
Yeah.
And the budget for the expedition is something in the order of $760,000.
Yeah, that's what I heard.
780,000. Enormously expensive.
Yeah.
Yeah.
Okay. Well, thanks, Michael, for that. Appreciate it. And Bob, what's on your bench these days?
Ken, I wasn't sleeping. I was just resting my eyes. I got to clear the bench off so I can see what's on it. I'm building a couple of ununs for some QRP antennas to go out into the field and work parks on the air. And I picked up an old True SDR, and it's probably 1,000 generations old. And nobody seems to have any documents or really accurate schematic on it. So I've got all the parts in, powered it up, and it lights up so it's alive. But now I've got to go back and troubleshoot it to see what it is that needs to be corrected so that I can get it to work. And outside of that is trying to just take off those kits I have that are on the shelf of shame and get them all working again.
Oh, that sounds good.
And I'll see you guys. We'll communicate and hook up at Orlando.
Oh, that's great. I was just going to mention that as well. So I got your number there. Because I'm going to be down in Florida for about 5 weeks, I'm going to pick up a SIM card. So my current phone number obviously won't be current. But I got your number, so I'll give you a text when we're down there.
Okay, thanks a lot.
Look forward to seeing you, Bob. It's been a long time. Last time I think we met up was Brampton.
It was that field day.
Yeah.
I still have my cap.
I've lost more caps these days. I lost my Kingston club cap over in England last year. I lost my park cap down in Florida last February as well. It blew off into the Gulf. Those hats are just $25 a pop. Okay, thanks, Bob.
Yeah, looking forward to meeting you, Bob.
Dwayne, good evening. How's it going over in your shack? Oh, you're muted. You're muted, Dwayne.
Haven't been doing too much lately. Did the direct conversion receiver at from the Vienna Wireless Work Society was working on. Now we're going to go and changing it into a double sideband transceiver.
Oh.
I'm going to see about. I just etched up a couple of boards. One of them is the audio board, audio amplifier and mic amplifier, and I put a changeover relay in there for push to talk, and have to go and do some of the other stuff a little bit later to start finishing it up like that. And in the meantime, there's always the other home brewing that has to get done, and that's about it.
Well, I'm ashamed to say that I bought my home brew supplies, meaning this stuff. I forget how many months ago I was going to make a late summer batch. That didn't happen. I thought, well, I'll make a Christmas batch, and that didn't happen. And now I got to the point, well, I'm heading to Florida, so there's no point making a batch before I go because, well, I won't be here to drink it. So I'll have to make do when I get back. I have a question for you, Dwayne. Are you going to 4 Days in May this year?
I'm not sure if I will or not. We usually go up to see my daughter at in the same trip, but it's been because of all the COVID stuff. We haven't been up there for a couple of years, so I might just bypass that and just go up and spend more time up there with her.
Okay, yeah, I just thought I'd ask. I haven't gone I've missed the last 3, but I will be going this year for sure. Okay, and when you got your board up there, that looks good. Good stuff there. Dave got his CNC machine going and is going gangbusters there and producing some pretty nice boards. So I got some of his specs that he's using, and one of these days I'll get around to changing it, and because he's getting much better results than I am.
Yeah, this is toner transfer etching.
Yeah.
I just found some new paper. Switched over to using some glossy inkjet printer paper, photo paper.
Yeah.
And it's unbelievable. You don't even have to wash it off with water. The paper off with water, it just peels right off when you're done.
Oh, that's good.
And it's really, really works nice. Makes life a whole lot easier. That board layout is kind of somewhere switch between surface mount and direct components. Mounted on the top. Just made the layout so I can go and stick a surface mount component if I got the right value, or if I need like a leader resistor or something. The pads are big enough I can solder them on directly.
Yeah, that's good. Yeah, I've just started to do boards now where I'm putting some components on the bottom side and the other components on the top, and that kind of thing. A little bit of a mix match. Okay, thanks for that, Dwayne. Good evening, Wayne. How are you tonight? No, you're muted, Wayne. Well, at least I can't hear you anyway. Nothing yet.
Okay, I'll go old school. Can you hear me?
Yeah, we hear you now.
Okay. So I kind of took a long break during Christmas, which extended until about last week. So I hadn't done anything up till then. I've picked up some Q factor measurements, things that I left standing by that I wanted to look at. And this week I've been looking at a number of the variable capacitors I have just to see if I can get a reading on the Q factors across a range of frequencies for those. And as a result of the talk that I gave earlier on this, I had come across a few toroids that looked a little bit dubious, and I wanted to find out if my junk box is full of bad toroids from manufacturers that are other than Amidon. I usually buy from a guy I know on eBay, not a Chinese gentleman, but somebody from Greece. And I was noticing when I was doing some measurements that different toroids with similar windings did not compare very well. So if I can conclude that there are some places that you don't want to buy from, I'll be bringing that back when I have my next chance at this. So that's what I've been doing. It's all fun. I actually quite like measuring at the bench. It's very it's relaxing. I don't know. It's like doing a crossword puzzle. Kind of easy stuff. And that's it.
I like measuring too. The unfortunate thing is measuring stuff usually ends up leading you down a rabbit hole.
Mm-hmm.
And Q, Q has been mentioned now, I think, the last 3 months or so, that conversation has been cropping up more and more. So I can see a rabbit hole developing with this one. So maybe while I'm down in Florida, like I don't have enough to do, I'll start paying attention to some of those conversations or those readings as well. because I think it's gonna come up. Okay, thanks, Wayne. And Howard, I see you managed to join us tonight. I can't remember when you popped in there, but good evening, Howard. What's on your bench?
Oh yeah, thanks, Peter. So yeah, sorry, I had another commitment. So
well, we had the best presentations tonight that you would have ever seen, but you missed them, unfortunately. So you'll have to catch the movie when it comes up.
Well, it's recorded anyway. So.
Yeah.
But yeah, not much. We're just finishing the SDR transceiver or SDT transceiver, and Peter was helping me earlier today. I haven't used my signal generator very much, and I'm going to need it to test the board for the INQ outputs. So he was helping me with that. So that's pretty well what I've been focusing on. And I was reading on the group IO about people that I guess are further ahead than me starting to build front panels for the cases, and they're using CNC machines to cut acrylic pieces. So I don't know if that's a mechanical way to cut it, or one person mentioned laser cutter. I don't know if you would have that at home, but that's kind of an interesting idea. I don't know if there's commercial places around here that do that.
I wouldn't be surprised if you could find something for that, Howard. Don't know where, but Googling will probably crop up something. You can get laser attachments for these, the CNC machines that like Dave and I have, and but how well they work with acrylic, I don't know. I know I've seen some conversations where they've talked about when they're mechanically routing out an acrylic panel, and they've had they're overheat. It's easy to overheat, so you're actually starting to melt it. So I guess it's slow speeds and all that kind of stuff to cut through it. But I have no experience with that one. But anyway,
yeah.
Well, if you're starting to think about casing, I don't think you're quite close to that one yet. But it's interesting that you're starting to pay attention to the different type of cases.
Yeah, well, there's a couple of people that this one fellow that talked about the acrylic, he's putting his in a Heathkit, repurposed Heathkit case. So I kind of want to do that, not necessarily Heathkit, but something. So I'm a long way from fashioning that. But I thought
when you go to Hamfest, Howard, you can start looking for these junkers that are going for nothing, right? Especially at the very end of the flea market, like the last we went up to, just up, I forget which one it was, just between here and Ottawa. I forget which one that one was now. But anyway, when we were leaving there, we looked at one rig and or some stuff there, and the guy almost gave it to us to take away. I just didn't want to carry it to take it home. But then again, it weighed a ton, so I didn't want to take it home either.
Yeah, I'm kind of hoping to in the summer start looking for something like that.
Yes. Well, come on down to Hamcation and see what you can find.
Yeah, I'd like to, especially with this weather.
Hey, you know what? You got a pilot's license. How much would it cost to rent a Cessna and fly down there and back?
Well, the friends I fly, his plane, it's pretty inefficient. Like it would be about $250 an hour times.
Yikes!
6 hours.
Can you afford that?
And that's why I said it's not very efficient.
Wow. Okay, so I'll forget that. I thought I was onto something there.
No, the fuel alone is $150 an hour.
Oh God. Okay, so we won't go that route. I was just thinking, we could have a handheld up that high up in the air and talk to every repeater known to across the eastern.
Yeah, that's true. That's true.
Okay, I don't think I missed anybody. Howard was last on my list. So anybody else have any other comments, questions before we go? Okay, great. Well, hearing none, thanks everybody for joining us tonight. It's been great. And I guess our next one will be February 15th, the regular meeting. Ken will be hosting that one, and I'll join in from Florida. Don't know why I keep saying that, but we'll see you guys then. And I plan to be on the air at some point. Probably I'll aim for the Mondays. But if I have any time coming up where the family's doing something else that I don't want to do, and I'll stay at the house. So I'll send an email out and see if anybody's available. Okay, I guess with that, we'll say 7-3 to everybody, and we'll see some of you at Hamcation, and we'll catch up with you later. Take care.
Okay.
Hey,
thanks.
Peter, Peter and Eric, hang
Good
back
night.
for a minute.
Yeah, I'll just take a quick break, and I'll be right back.
Yeah.
Okay, good night, everybody.